now going to show you the calculator functions for an example we did previously. So we're looking to calculate the mean and standard deviation of this discrete distribution. So what we're going to do is we're going to enter this data into the calculator. The x values I'm going to put into list 1, the probabilities I'm going to put into list 2. It doesn't matter which list you put them into, just make sure that you label them accordingly when you're actually running the function. So if you recall, the lists are under the stat key, and we're going to hit enter for the lists. So I want to use these two lists, so I want to clear out my top list, my list 1 here. You highlight the L1 and you hit the clear button and then enter. Do not hit delete. If you hit delete, it's going to remove the entire row and you'll have to set up editor to get it back. At any rate, I'm going to list these values. So those are my values for x. My probability of x go into list 2, and they have to go in the same order that I had them in before. No sorting, please. Let's just verify we have the proper information here. And we do not. So I need to change this value here. I put in 0.06, it should be 0.03. And now we're good. Alright, I'm going to show you a large view. Alright, so we have the large screen now. We have all the data in from the actual values. So what we're going to do is we're going to use the one variable statistics, much like what we did with earlier stuff, just calculating the regular x bar and s, although we won't be doing exactly the same thing. So I'm going to hit the stat key, go over to calculate, and hit enter. Alright, this will look a little bit differently than it will on a TI-83. You won't get this list and frequency list. You're going to have to tell it list 1, comma list 2. Our frequency list will be list 2, so second 2. And the x bar value is our mean. If you recall, our mean was 1.49. There is no S of x because this isn't a sample, so there's no sample standard deviation. There is, however, sigma of x, so this is the population standard deviation, or 0.9327 is what we calculated on the previous example. Now this doesn't give us our value of sigma squared, similar to what we did before. We're going to have to raise this to the second power to find the variance. So if we want the variance, I'll take 0.9327 and raise it to the second power. And that was our variance from before. We're very close to it.